and I'm restarting recording. Okay, so we've just finished talking with Mike Ostling. I'm going to come back and share screen a little bit. And we finished our celebrity interview. Just want to touch base on our Lean movie this week. So we had Bill Peterson talk about Lean applied to us. And we're just talking to Mike Ostling. One of the things he was talking about, one of his favorite tools was leader standard work. And in Lean Applied to Us, Bill was giving you some of the things that you can maybe sort of personally do in how you manage yourself from a Lean perspective. Anybody in the class have some comments or some insights on what they heard in that video? Anybody start to apply some of those things in their own work lives? Just to kind of put the pressure on, let's see, we get the participants here. Yeah, Cassie, what do you think? A good idea there somewhere?
Yeah. One of the areas he talked about, and I forget which waste it actually applied to, but it was too many tasks at once or too many projects at once.
Yeah.
And, I've always wanted to do it all and be it all for everybody and say yes, and then you realize that you're just drowning and not being efficient or productive. And so over my years in management, like I have 2 or 3 big projects I'm working on, and someone mentioned another project and I said, nope, not until these are done. And so, and everyone's okay with it, but it just takes, I don't know if it's learning from your failures and stuff, is projects are so much better and so much more timely and effective by not taking on too many of them.
Right, and doing them in sequence and eliminating that switching back and forth, which is so much of a waste and things. So yeah, good observation. Thanks, Cassie. Anybody else, other ideas that really struck home for them in that video? Yeah, Charles, observation.
Yeah, so one of the things that I picked up on when I was watching the video was about how the speaker made comments about how oftentimes in tasks that you may be going through on a daily or weekly basis, you view them as being productive, when really it's helpful to take a step back and engage other maybe other individuals or apply some Lean concepts to really question whether or not these tasks that you do are all that productive, or maybe there's a better way of doing things.
Right. Yeah, so sometimes that stepping back, getting that outside perspective, I know one of the things we talk a lot about in Lean is the idea of learning to see. And we get so immersed in the things we do, we don't take the time to step back and really sort of observe, is this really adding value? Is this the best way to do things? So yeah, I appreciate that concept. Judy, do you have an observation?
I just wanted to kind of touch on that also, and say that it kind of reminded me of what I kind of think of as benign neglect, with kind of the stepping back process when tasks are handed around. If it's not a task you take on for yourself, it's really easy for other people, especially people who are not doing the job, to prioritize tasks for you or attempt to do so. And sometimes a little benign neglect, I think I'll change that to stepping back and contemplating, actually proves that once the first fire of enthusiasm for it is gone, there isn't much justification behind the task other than just being able to count piles of things that people did.
Right. And I think too, a lot of times when people are assigning projects, if they don't actually have to do the work, and it's sort of out of sight, out of mind, you know, they lose track of whether there's sort of really the value there, right? And when the spotlight goes off, right, or the fire dies down, you really got to come back and reassess on those things. Should we keep on doing them, right?
Exactly, agreed. And it turns into very interesting conversations when you ask, why do you need that done? Why should I do that? Why should I prioritize that over other things?
Yeah. You know, one of the things that I hope a lot of you are getting out of this class as we talk about these things, there are the, you know, sort of the DMAIC process and these lean tools, but we're also trying to develop a way of thinking about processes and operations and values and customers and how this fits together, and what should our real approach be to you know, improving organizations and improving operations. So I think this is all good information and good things to be thinking about. And I like the way you guys are starting to think and challenge the status quo. Any other observations on the movie? So we've got our next video. It's another TED Talk. Ted Hartford's going to talk about frustration causing effectiveness. And we're going to look at that a little bit from a lean perspective, stretch your thinking a little bit now that you're getting a little bit sharper on this stuff. So I look forward to talking about that next time. And then the last video that we're going to be looking at for this class is Right the First Time, which is a classic. And you should be looking forward to that too. All right, so moving on now. Let's see here. So in tips and tricks this time, I just want to share with you, we talked a little bit about certification projects. This is a little chart that shows you what the certification requirements are for green belt and black belt projects. It's also another place to pick up the, you know, what tools apply in what area. So you've got your define phase here. And you've got, you know, for a green belt project, you have to do all these tools in the define phase, you know, same thing in the black belt, and then down in the measure, and then down in the analyze section, there's a little bit of a select 3 versus select 4. One thing that in certification at Cal Poly for black belt, one of the things you got to do is you've got to do a design of experiments type of analysis is one of the things that you have to do as a requirement. Actually, for our certification, I'm going to expand that. If you don't, we could also, as opposed to doing a full design of experiments, you could do a fairly rigorous multiple regression analysis would also be acceptable for that. Tends to be a little bit more applicable in some of the real world situations that some of you students are dealing with. Anyway, if you want to, you know, look at this more fully, this is in the certification syllabus that's posted on the Central Coast Lean website. So if you go to Central Coast Lean and you click on the Six Sigma tab, you'll see some places where you can see the syllabi for the green belt and the black belt. The transactional green belt would be same as the green belt here. We just, you know, tune the particular tool applications to your specific application, if you will. Any questions about that for the tips and tricks portion tonight? Okay, I'm going to go ahead and let's see here, move this up a little bit. All right. So for highlights, so this is hypothesis testing. So one of the things, you know, getting to these hypothesis tests, you know, there's so many different statistical tests you can use. It's always good to walk through sort of a decision tree type approach to understand the requirements for the type of test that you're going to use, which is a big thing. I want to sort of walk through with you a little bit about this, types of errors that you're looking at. Now, I know in MoreSteam, when they talk about this, they're big on the judge and jury type approach or analogy to hypothesis testing. So you've got the jury's verdict. So you got the jury's verdict of guilty or not guilty, and then you've got the actual guilt or innocence of that person. I don't know. I never found this sort of approach or this sort of analogy super useful. Maybe I don't watch enough court TV to really sort of appreciate it. I've overwritten this with a little bit of this red writing is some of the things that I sort of think when I approach this. So there's what you say. So that's on the left-hand side there. And I'm going to say that I'm going to reject the null hypothesis, or I'm going to say that there's no difference, or I'm going to say that there is a difference between my two samples, or between the null, or between a normal distribution and what this thing is. So that's my rejection. There is a difference, or I'm going to say there's no difference. Then I'm going to go up and there's the reality of what really is. So it could either be I was correct in rejecting, there was a difference, or there was no difference. So that's what the reality of the situation is. So I get a type 1 or alpha error. That's where I'm looking at that sort of 5% level. So I've got a 1 or 5 in 100 chance of making an error. So if I do this thing 100 times, 5 times out of 100, it's going to have this type of error just by random chance, right? So if I say that I should reject it and there really is no difference, so I said that it is different, the two samples are different, and there's no difference, I've made an alpha or a type 1 error. If I do reject it and it's supposed to be rejected, I've come up with the correct verdict, or I've got it right essentially. On the other side of things, there's the beta error. And that's when I get into trouble because my sample size isn't big enough. I don't have enough of an effect size there is, but I say that there's no difference, right? So I'm looking at these two things. And I say that, okay, there's no difference between these things. So I go ahead and reject it, but I really shouldn't have rejected. There really is, some sort of difference. So I've made what's called a type 2 or a beta error in that process. So beta errors can be, overcome or improved by increasing your sample size or increasing the effect size to deal with that. And so if I do that and I've got a better sample size or a bigger difference that I'm looking at, I'm actually getting more power in my testing, and I'm able to detect smaller and smaller differences. So what I like to advise you is, for this section, hypothesis testing, you need to be able to go through and operate the engine room or the mini-tab as far as how to set up and how to do the test. The mechanics are very important. But I always want you to know that this sort of, susceptibility to error is going on there in the background, and you should be aware of it, okay? Any questions about hypothesis testing or the things that we saw in this section? Concerns? And I know my black belt folks are kind of getting into, different and more extensive tests than my green belt folks at this point. Okay, so I'm going to go ahead and move on. We're actually going to cover a little example of hypothesis testing. And I'm going to go to my St. Sigma example. So if you remember, we're looking at a glucose blood testing situation. And if I was sort of getting into it, I was getting ready to sort of do this analysis, I want to take a deep breath, take a step back, go back to the start of the section, and by this I'm talking about like the MoreSteam section, and this is the advice is, break your study into small pieces. Don't try to take on too much at a time. Use that hypothesis testing mat in the Stat Master, or there's a wizard in the engine room to understand the relationships or to select the specific tests. You want to focus on your hypothesis statement and the info needed for the test, not the formulas. So, I know you've all probably taken fairly involved statistics classes. It's good to sort of know that stuff, the formulas and things. But in this class, and from a practical business sort of standpoint, we're just asking, can you execute the test and interpret the results? And by all means, you start out by asking good questions like how much or why, or is this really different, for example. So here's the hypothesis test process. Like everything has a process. So you're stating the null and alternative hypothesis. You'll get the decision criteria, or you pick the alpha level. That's going to determine your type 1 error or your susceptibility to type 1 error. You're going to collect the data, and you're not going to calculate the statistics, but the software is going to calculate your statistic. And then you're going to state your conclusion, right? You're going to either accept or reject the null hypothesis. And then ultimately, you're going to have to translate that back into some business language that people are going to understand and you're going to have to implement in the real world. So here's the little story of, I'm not going to actually go into the statistical software, but I'm going to sort of walk you through it here. But you're called in as a black belt expert to help St. Sigma. And, one of the questions, the practical world management question, is this stat designation really helping? So as we know at St. Sigma, they can designate it either routine or stat. And they want to know if stat is really getting this stuff through the system faster. So first off, I'm going to get a feel for the data. I'm going to plot it. I'm actually showing you a couple screens from Minitab, where they have this sort of, if you give them a distribution, they print out some summary statistics and give you a little histogram distribution overlaid with a normal curve. They've got some data on some different aspects of the data. You can kind of look there on that side panel. But I've got a plot on the left of what it looks like when the glucose test is marked routine. And then there's a plot of what it looks like when the order priority is stat. All right, so first I've got a feel for the data. I look at the data. It kind of looks like the data for the stat is skewed more to the left. I can look at the mean values. It looks like the mean is definitely lower, right? But is it really significantly different? That's my question. And I'm saying I'm going to plot it again. There's different, things you can plot. Here it is plotted as a dot plot, where I've got the routine versus the stat. It's got some dots as to what the distribution looks like. You can never plot this stuff too much. And then, I've got another question as to, well, what kind of sample size am I going to need in order to see if these distributions are really different? And I'm going to pull a subset of data. So, before I go ahead and collect, 100 data points, I'm going to find out how much time I need. And I'm going to do a sort of a smaller sample size. Maybe I sample, a dozen different times, or 12 of each of the routine, 12 of the stat. And I look at that, and I come in and I put it in my sample size calculator. And I've also got some input for management as to how big a difference or how big an effect size should I really be looking for. So that was one of the things we talked about when we were looking at the power of the test and our susceptibility to a type 2 error. Well, I say I'm going to look for, even a 10% or 10-minute difference could be a difference between life and death. So I'm going to use that in my calculator for my effect size. And I go in my calculator. This is one of the Excel spreadsheet calculators that I've provided for you from MoreSteam. and you just have to put in what the current standard deviation is for my sample, the delta, so my 10-minute difference, I've broken that into plus or minus 5 minutes. I picked an alpha level 0.05, and in order to get identify a significant result, it says I need a sample size of about 132 as far as a sample size, okay? So that would be maybe one tool I would apply in the analyze, a calculation of a sample size. And then I'm going to go ahead and plot it again. Now I've plotted my bigger distribution, my larger sample size of 132 to see what the differences look like. I've plotted both as a normal distribution and as a box plot. So I'm getting a good visual feel for what that data looks like. I'm going to go by and try to figure out which hypothesis test tool I should use. I know I'm looking at variable data, right? So I've got this routine data is in terms of time, and that's variable. I've got, I'm looking at the difference of the means of the two samples. So I got a mean, I got two samples, I got routine and stat. I'm going to do the conservative thing and say, I'm going to say that my variances are unknown, right, which is more conservative. I'm going to, also say that, I'm going to assume that they're unequal, and then sort of come down here, and it looks like no matter which one of these, paths I take, I'm going to wind up with a two-sample t-test. So that's what I'm actually going to perform. So I'm going to go to my statistical software, do a two-sample t-test. And when I do that, here's the output from the test. Well, of course, first I've stated my null and alternative hypothesis. My null hypothesis is the no difference, right? That's a null, right? So there's no difference between the times for the two priorities. And then my alternative is that the stat priority designation is at least 10 minutes faster. So I've done my t-test, prints out, and this was done in Minitab also, but it prints out the different means, the different standard deviations for the two populations or the two samples. And it's looking at the difference between those, the mean of routine and the mean of stat. The estimated difference is about 36 minutes. The lower bound for the difference at the 95% confidence interval is 31.48 minutes. And I'm looking at my p-value. My p-value is 0.000, or it's definitely smaller than 0.05, which was my criteria as far as my test p-value goes. So I'm going to say yes. I'm going to reject the null hypothesis, and I'm going to accept, or I'm going to say that the likelihood is that the stat priority designation is at least 10 minutes faster. Okay. Just another point I want to make. We did a two-sample t-test. You're going to get the same result if you did a one-way ANOVA, a one-way analysis of variance. You'll get the same result as you did for a two-sample t-test. If you just got the two samples in your ANOVA. So when I do this, just give you a little bit different information. It gives me an adjusted R-square value. So that says that this difference explains about 38 or 39% of the difference between the routine and the stats. So that designation explains about 39% of the difference. And also the other reason why I like to do this, and this is in Minitab, is because it gives you this little confidence interval plot, right? So it's plotting out the 95% confidence interval. So here's the 95% confidence interval for the routine, and here's the 95% confidence interval for the stat, and you can kind of see what the difference is between those, okay? So it gives you a good positive sort of graphic that difference is significant, all right? And when you do an ANOVA, and I show you this just because, if we had, 3 different designations, say there was a routine and a stat and a super stat or whatnot. What the ANOVA test would tell you was that there were 2 of those are different, but it wouldn't necessarily tell you which ones are different. So if you ran a Tukey test or a post hoc test on that, which is possible in most statistical software packages, you can tell which ones are exactly different. So here it's telling me that the difference between the routine and stat at the 95% confidence level could be as much as 41 minutes or as little as 30 minutes. And it shows you the sort of the 95% confidence interval on that difference between the 2. And then what I want to do is I want to go back to the practical world, and I don't want to give my manager a bunch of statistical mumbo jumbo. I want to assure them that I knew what I was doing when I did that. But in translating that to my manager, I would say with a 5% chance I'm wrong, a stat priority designation is worth at least a 30-minute reduction in turnaround time on average, right? And so that's what I'm always trying to get to, is that practical managerial implication for doing my statistical analysis. I think one of the problems with sort of the Six Sigma world, not so much in the lean world, but the Six Sigma folks get maybe a little bit of a bad rap for being very sort of numbers, statistically sort of driven. And unless you turn your language back into sort of this more practical sort of approach, people aren't going to ask you to come back to help them solve their problems. So that's where we want to be. So that's a little walk through a hypothesis test. Any questions on that from anyone? Just work through it systematically, one step at a time. When you provide me your tools, so everybody in their mini project has to do at least one statistical tool, and by statistical tool, it's got to be either some sort of hypothesis test, single sample, 2 sample, confidence interval, something like that. In there as part of your project. The other thing you can do is you can do a control chart as your statistical tool, but you'll have to talk about your control chart in the sort of terms of a hypothesis test. So what does it mean from a hypothesis standpoint? You're assuming that the distribution is normal within the upper and lower control limits of your hypothesis test. When something goes outside the bounds of those upper and lower limits, then you're essentially rejecting the null hypothesis. Something is different. Something is potentially out of control. So you've rejected the null hypothesis. So that's how you would apply sort of a statistical interpretation or a hypothesis interpretation to a control chart. Any questions? I'm going to go ahead and move on at this point. Okay. Seeing none, I'm going to go ahead and go on. Hidden gems, one thing there is within those MoreSteam Excel templates, which are on the Fullerton portal. And I really recommend, before you leave this class, make sure you get your memory stick or wherever you sort of put these things, download all those Excel templates. They're going to be invaluable to you in your workplace when you don't have easy access to statistical software. But one of them is a chi-square test for normality. A lot of these tests require an assumption of normality of the data. And these normality tests tend to be embedded in a lot of places. We use that Anderson-Darlington test. You'll see that a lot. But if you just want to, look at a standalone normality test, that's available in that Excel template. Okay, well, that's another night of dealing with Lean Six Sigma. You got a mini project that's due on Sunday. Any questions at this point on anything in the material or anything in the course that I can answer or help you guys with?
I just have one last question, and maybe you mentioned it at the beginning of the course this evening. For the one of the things you were talking about was the practice test.
Right.
And for the transactional students, is that optional, or is that required, or is it not? Are we not able to do it, or what? I think I missed that part.
So once again, what we'll do is for the transactional Greenbelt folks, if you're interested in proceeding on to certification, so we'll give you that practice test, you know, more closer to when you're actually going to take that final exam, right? As opposed to taking it now and then, you know, you forget everything you learned in 3 months and then you have to go take the real test. So we're going to put the practice test closer to the real test for the transactional folks, okay?
Okay, perfect.
All right. Other questions? Okay. Well, oh, yes, Judy, what's your question?
Yeah, looking at the list of assignments, I see that CTQC survey, and I don't see that anywhere on the syllabus. Am I just missing it?
No, you're not missing it. So that survey, I would like you to fill that out, but it's optional.
Okay.
So you don't get points one or the other, but it's a nice thing to do.
Okay.
Yeah, shouldn't take you much time, and I'd appreciate if you'd fill that out.
Sure.
All right. Let's see, Michael, you got a question?
Hey, yeah, I was just wondering, we did a little bit of work with the 5S from the Gimba Academy. Do we need to do any more with that?
No, that's kind of it at this point. I think it's covered in MoreSteam in the control section.
Okay.
You know, they do some 5S stuff in there, but we're probably not going to talk about it directly anymore in the class unless it comes up.
Okay.
All
Cool.
right.
And then I sent you an email, but I was asking if you were going to be around tomorrow afternoon.
Yeah, I should be.
Okay, cool. I think I'll stop by and ask you a couple more questions.
Okay, and you're trying to get your project lined up too and stuff. I've been watching the email traffic there. So
Right. Yeah. Exactly. Yeah.
Okay. Yeah. No. Happy to talk to you about that. It's good. It sounds like you got some options.
Yeah. Yeah. I'll run them by you tomorrow.
All right. Sounds good, Michael.
Okay. Thanks.
Sure. Anybody else? Okay, with that, everybody have a good evening. If you want to stop by and have some corn on the cob at a Hobnob this Friday and you're in San Luis Obispo, I look forward to seeing you. Okay, take care.
Thanks.
All right, bye.